In this video, I'm going to use the CX300 to test and align a mobile duplexer UHF band. So to start out with, the CX300 has been set to factory defaults. Actually, it's just booted up. So I'm going to go to the grid and I'm going to select my spectrum analyzer. Say done. And here's the spectrum analyzer. So I'm going to use a kind of the large menu selection here to configure the instrument. This particular duplexer, I'm going to configure for 460 megahertz and 465 megahertz. Those will be the pass and reject bands. So I'm going to use my RF input port. It's the higher sensitivity port. I want to set my top of scale reference line to plus 15 dBm. I'm going to set my attenuation to manual mode, and I'm going to give it 10 dB of input attenuation, and I'm going to change my scale per division to 15 dB per division. I'm going to leave my frequency mode to center span. I want to change my span first to 10 megahertz. That's the window size that I want. And since my two targets are 460 and 465, I'm going to set my center frequency to 462.5, shoot right in the middle. And we'll go down to bandwidth. I'm going to set this to manual mode also. And I'm going to change the resolution bandwidth to 10 kilohertz. This will give me a little bit lower noise floor. And then on my trace, I'm going to set my trace mode to average. And I'm going to set my detector type to negative peak. I'm going to leave my average count at 1 so the refresh rate will be faster, but later on, if I want to settle out the noise, I can come back into this menu and set this average count to 2 or 3 to help with the averaging. I'm going to skip some of these things for now. I'll scroll down the menu. And we'll go down to the tracking generator section. I'm going to set the output port first to do RF output instead of RF duplex, because I can get more signal out of the RF output port. And I'm going to set that level to plus 5 dBm. And I'll enable that. And let's just take a look at where we're at. So right here, I can see roughly this is my noise floor. That's going to be low enough for what I'm doing today. So I don't need to do any further optimizations. So the first thing I need to do is I need 2 test cables. And I've got one cable connected to my RF output port, and I have another cable connected to my RF input port. I'm going to connect these 2 test cables together so that I can do a calibration to eliminate any loss that's in those test cables, so those are not a factor in the insertion loss measurement. So to do that, I'll open up this top menu, back out, and I'll go to trace. I'm going to set this as a reference trace. So that took a snapshot of this, and I'm going to go to reference mode. And now that's a 0 reference. So it's zeroed out any loss those two test cables have. So those are no longer a factor in the measurement. So now I'm going to connect my RF input port to the duplexer's antenna port. And I'm going to connect my RF output to the low side of my duplexer. And I have a 50 ohm termination connected on the high side. And this is what I'm seeing. I'm going to turn on a couple of markers with this marker icon. I'm going to set marker 1 to 460 megahertz because that's a target. And I'm going to click on this marker function and select a marker 2. And I'm going to set it to 465 megahertz. So now I have 2 markers enabled. I can change this to the marker table so I can see the levels of each marker. So right now I can see I have 0.96 dB insertion loss in my pass band, and currently it's at minus 105 area. And just quickly, I'm going to swap my load and cable so we can see the other side real quick, just to see what we're starting with. So there on this side, I got minus 90 roughly and 1.15 dB insertion loss. So this duplexer has a minimum isolation specification of 75 dB. So I'm going to use a horizontal marker. We'll go back to markers, change this to horizontal. We'll turn this on, and I'm going to set a minus 75 dB marker. So I will want any notches to be below this line. So I'm in good shape so far. So this duplexer has actually already been tuned. So I'm going to detune it now, and we'll bring it back into alignment. So there I've kind of detuned it pretty drastically. So tuning one pole, tune another pole. And I'm just tuning it to the marker location. So that looks pretty good there, and I'm below my marker of minus 75. So now I'm going to move my cable from the high side to the low side, and I'm going to swap my 50 ohm termination. And there it is. So let's tune on it some as well. So I've changed all 3 poles. I want to bring this one back to the marker. Next pole. And the 3rd. Okay, so now if I wanted to see this with a little better detail, I can open up, and I'm going to set my average count to like 3. Let's try that. I'll move this just a little bit. It looks pretty good. We'll turn on the marker table. So marker 2, I've gotten a bit in the area of 100 dB and 1 dB insertion loss in the pass band. And if I like, I'll go ahead and leave it like that. I'm going to swap the cables. And I've got about 95 dB roughly and minus 1 dB insertion loss in the pass band. Other things I can do is I can come up, I can set this trace type to capture. Now that one's locked in, and I can select a second trace. I'll set it to average, and I'll move my cable and load again. So now I've got a view of both sides. And the marker's measuring the live trace. On marker 2, like marker 1 is measuring the captured trace. And if I like, I can use this camera icon and take a snapshot of that, and it just created a file name and it shows it was a quick save. Now we can take this a step further, and I can open a new tab and bring up a network analyzer. And I'm going to go into this menu here, and I'm going to set the span for 10 megahertz, center frequency of 462.5 megahertz. I want to measure return loss. I'm going to set the data points to 460. And let's again turn on some markers. 460 megahertz. Oh, span I didn't set right. 10 megahertz. And let's set marker 2 to 465 megahertz. So I'm going to put a 50 ohm termination on the antenna port and on the high side, so my generate output port on the CX300 is connected to the low side. So I can see with the VNA, the return loss, I might possibly move that just slightly. So I'll try tuning that just a little. It was just a very minor. So there it is with the VNA. I want to move it to the high side. So I swap my load and cable. Just a minor touch there. So I'll take another picture of that. Maybe let's do the same thing. Let's go in, do a trace, change this to capture. And I'll enable trace 2, set it to clear and right. I'll move my cable back over. And take a picture of this as well. So I've saved 2 screenshots of that. And I think we're aligned and documented.